Welcome to our introduction to regular expressions. Today we're going to explore one of the most powerful tools in text processing. Regular expressions, or regex for short, are powerful language for working with text. Whether you're validating email addresses, searching through log files, or transforming text data, regex is an essential skill in any developer's toolkit. Let's begin our journey into the world of pattern matching. Before we dive into the details, let's clarify what we'll achieve in this session. By the end of this presentation, you'll understand how regular expressions work and why they're so valuable. You'll learn the basic building blocks of regex patterns and how to combine them effectively. Most importantly, you'll gain practical experience through examples and exercises that demonstrate real-world applications of regex. Think of these objectives as our roadmap for mastering pattern matching. Regular expressions are special text patterns that describe what we want to match in a string. Think of them as a search query on steroids. Instead of just searching for exact text, regex allows us to define patterns that can match multiple variations of text. For example, instead of searching for a specific email address, we can create a pattern that matches any valid email address. This flexibility makes regex incredibly powerful for tasks like validation, search, and text transformation. The pattern you see above is actually a regex that can validate email addresses. We'll break down how it works later in the presentation. Let's start with the simplest form of regex patterns, literal characters. When you write a regular expression using normal letters, numbers, or symbols, they match exactly those characters in the text. For instance, if you write the pattern cat, it will match the word cat and only cat. It won't match cat because regex is case-sensitive by default, or cats, because there's an extra character. However, certain characters have special meanings in regex, which we call meta characters. If you want to match these special characters literally, you need to escape them with a backslash. This is just like how you might need to escape characters in programming language strings. Special characters, or meta characters, are what give regex its power. Each one has a specific meaning that goes beyond matching the literal character. The dot is probably the most commonly used. It's a wildcard that matches any single character except a new line. The asterisk and plus are quantifiers that let us match repeated patterns. Square brackets let us define custom character classes, while parentheses group parts of our pattern together. When you need to match these characters literally in your text, you need to escape them with a backslash. For example, to match an actual period, you'd write backslash instead of just dot in your pattern. Understanding these special characters and how to use them is crucial for writing effective regular expressions. Character classes are one of the most versatile features in regular expressions. They allow us to define a set of characters, any one of which can match at that position in the pattern. Think of them as creating a menu of acceptable characters. When you put characters in square brackets, you're saying, match any one of these characters. You can list them individually like, A, E, I, O, U, for vowels, or use ranges like, 0 to 9, for digits or, A, Z, for lowercase letters. The caret symbol caret at the start of a character class inverts it, so, caret 0-9, means, match anything that's not a digit. This is incredibly useful when you want to match everything except certain characters. Character classes are fundamental building blocks for more complex patterns. Quantifiers are how we specify repetition in regular expressions. They tell us how many times a character or group should appear. The asterisk means 0 or more times. It's very flexible and will match whether the character appears or not. The plus sign means 1 or more times. It's like the asterisk but requires at least one match. The question mark means 0 or 1 time. It makes something optional. When you need more precise control, you can use curly braces. For example, 3 means exactly 3 times, while 2, 4 means between 2 and 4 times. These quantifiers can be applied to single characters, character classes, or groups, giving us powerful ways to describe patterns with varying lengths. Anchors and boundaries are special markers that don't match actual characters but instead match positions in the text. They're crucial for ensuring your patterns match in the right context. The caret symbol matches the beginning of a line or string, while the $$ symbol matches the end. Word boundaries, \b, are particularly useful. They match the position between a word character and a non-word character. This makes them perfect for matching whole words. For example, if you want to match the word cat but not category, you'd use \cat\b. The \b is the opposite of \b, it matches positions where \b doesn't match. These position markers help us create more precise patterns that match only in specific contexts. Groups serve multiple purposes in regular expressions. First, they allow us to apply quantifiers to multiple characters at once. Second, they capture the matched text for later use. These are called capturing groups. When you put parentheses around part of your pattern, that creates a group. You can then reference what was matched by that group later in your pattern using back references like \1, \2, etc. The vertical bar within a group creates alternatives. Cat-dog matches either cat or dog. Sometimes you don't need to capture the group's match, that's when you use a non-capturing group with. This is more efficient when you just need grouping without back references. Groups are essential for creating complex patterns and extracting specific parts of matched text. Regex is particularly powerful for data validation scenarios. When dealing with user input or data processing, we often need to verify that data follows specific formats. For times, we can ensure values are between midnight and 23:59. Currency validation can check for proper decimal places and currency symbols. URL validation can verify proper protocol and domain structure. These patterns help maintain data integrity and improve user experience by catching errors early. The beauty of regex is that we can combine multiple validation rules into a single pattern, making our validation logic both powerful and concise. Testing regular expressions is crucial for ensuring they work as intended. A methodical approach to testing helps catch edge cases and prevents potential issues. I recommend starting with simple patterns and gradually adding complexity. Use online regex testers. They provide instant feedback and help visualize how your pattern matches different inputs. When working with complex patterns, break them down into smaller pieces and test each piece independently. It's also important to document your regex patterns with comments explaining what each part does. This makes maintenance easier, especially when you need to modify patterns months later. Remember, a well-tested regex pattern is a reliable regex pattern. Performance is a critical consideration when writing regular expressions, especially when dealing with large texts or frequent operations. One of the biggest performance killers is excessive backtracking, where the regex engine has to try multiple possibilities to find a match. To avoid this, be as specific as possible with your patterns. Instead of using greedy quantifiers like asterisk that match everything, use more specific character classes or atomic groups. Anchors can also help by telling the engine exactly where to look for matches. Always test your patterns with large inputs to ensure they perform well at scale. Remember, a more specific pattern might be longer to write, but it will usually perform better than an overly general one. Having the right tools can make learning and working with regular expressions much easier. Online tools like regex101.com are fantastic for testing and debugging your patterns. They provide real-time feedback and detailed explanations of how your pattern works. IDE integration is also important. most modern development environments have built-in regex support with syntax highlighting and testing capabilities. For learning, there are many great resources available. Online documentation provides comprehensive reference material, while practice exercises help build practical skills. Pattern libraries can give you ready-to-use solutions for common problems. Don't forget about the power of community forums where you can get help with specific regex challenges. We've covered a lot of ground in this introduction to regular expressions. Remember that regex is a powerful tool that becomes more valuable as you practice and apply it to real-world problems. We started with the basics of pattern matching and progressed through more advanced concepts like groups, quantifiers, and optimization. The key to mastering regex is understanding not just how to write patterns, but when and where to use them effectively. Keep practicing, refer to the resources we discussed, and don't hesitate to break down complex patterns into smaller, manageable pieces. Thank you for your attention, and I encourage you to start applying these concepts in your own projects. Now it's time to put what we've learned into practice. Let's work through some real-world examples together. We'll start with common patterns like email validation and gradually move to more complex scenarios. Feel free to ask questions as we go along. Remember, there's often more than one way to write a pattern to achieve the same result. We can discuss the pros and cons of different approaches. The goal is to build your confidence in writing and understanding regular expressions through hands-on practice. Let's start with these exercises and then we can address any specific scenarios you'd like to explore.